Hello everyone, this is Hemashri pursuing BE Computer Science Engineering at Sri Venkateswara College of Engineering. Here in this video we're gonna study the topic Design and Analysis of Algorithms. Under this topic we're gonna discuss what is an algorithm, properties of algorithm, types of algorithms, algorithm design, algorithm analysis, mathematical analysis of non-recursive and recursive functions, real-world applications and its limitations. What is an algorithm? An algorithm is a set of instructions that a computer or human follows to solve a problem. It is essentially a step-by-step process that can be used to solve a wide range of problems from simple arithmetic calculations to complex data analysis. Algorithms are important because they allow us to automate repetitive tasks, optimize process and make better decisions based on data analysis. For example, imagine you need to sort a list of names in alphabetical order. You could manually compare each name and rearrange them one by one, but this would be time consuming and prone to errors. Instead, you could use an algorithm like the quicksort algorithm, which can efficiently sort large amount of data in a matter of seconds. This not only saves time but also ensures accuracy and consistency. Properties of algorithm. Efficiency. Algorithms should be efficient in terms of time and space complexity. This means that they should be able to solve problems within a reasonable amount of time and use a reasonable amount of memory. Correctness. Algorithms should produce correct results for all possible inputs. This means that they should be designed to handle edge cases and unexpected inputs. Robustness. Algorithms should be able to handle errors and exceptions gracefully. This means that they should be designed to recover from errors and continue processing. Modularity. Algorithms should be designed in a modular way with separate components that can be easily modified or replaced. This allows for easier maintenance and scalability. Types of algorithm. Sorting algorithms are used to put a collection of data in a specific order. One example is the bubble sort algorithm, which compares adjacent elements and swaps them if they are in the wrong order. Searching algorithms are used to find a specific piece of data within a large collection. One example is the binary search algorithm, which works by repeatedly dividing the search interval in half until the target value is found or determined to be not in the collection. Optimization algorithms are used to find the best solution to a problem given certain constraint. One example is the linear programming algorithm, which is used to maximize or minimize a linear objective function subject to linear equality and inequality constraints. Algorithm design. Algorithm design is a complex process that involves identifying a problem, analyzing it thoroughly, and designing a solution. The first step in this process is problem identification, which involves recognizing the need for an algorithm to solve a particular problem. This requires a clear understanding of the problem and its constraints. The next step is problem analysis, which involves breaking down the problem into smaller, more manageable components. This allows the designer to identify patterns and relationships within the problem, which can then be used to develop a solution. Finally, solution design involves creating an algorithm that solves a problem efficiently and effectively. This requires careful consideration of factors such as time complexity, space complexity, and data structures. Algorithm analysis. When analyzing an algorithm, it is important to consider both its time complexity and space complexity. Time complexity refers to the amount of time it takes for an algorithm to complete its task, while space complexity refers to the amount of memory the algorithm requires to execute. One way to measure time complexity is by using big O notation, which expresses the upper bound of the number of operations an algorithm performs as a function of its input size. For example, an algorithm that performs a single operation for each element in a list of n elements would have a time complexity of O n. Similarly, an algorithm that performs a constant number of operations regardless of the input size would have a time complexity of O1. Space complexity can also be expressed as big O notation, representing the upper bound of the amount of memory an algorithm uses as a function of its input size. For example, an algorithm that creates a new list of n elements would have a space complexity of O(n), while an algorithm that uses a constant amount of memory regardless of the input size would have a space complexity of O(1). Mathematical analysis of non-recursive and recursive algorithms. Non-recursive algorithms. Non-recursive algorithms are the algorithms that do not call themselves. They are often easier to understand and implement than recursive algorithms. Recursive algorithms. Recursive algorithms are algorithms that call themselves. They are often used when a problem can be broken down into smaller subproblems that are similar to the original problem. Time complexity. Both non-recursive and recursive algorithms have time complexity, which is a measure of the amount of time it takes for an algorithm to run as a function of the size of the input. Space complexity. Both non-recursive and recursive algorithm have space complexity, which is a measure of the amount of memory an algorithm uses as a function of the size of the input. Real-world applications. Algorithms are used extensively in computer science, engineering, and finance. In computer science, algorithms are used to solve problems such as sorting and searching data. They are also used in artificial intelligence and machine learning applications. In engineering, algorithms are used to design and optimize systems such as aircraft and automobiles. They are also used in the development of new material and technologies. In finance, algorithms are used for trading and risk management and portfolio optimization. Limitations. Despite its impressive performance, the algorithm has some limitations. One major limitation is its dependence on large amount of training data, which can be difficult and expensive to obtain. Additionally, the algorithm may not be suitable for certain types of data or applications, such as those with high level of noise or variability. Future of algorithms. As technology continues to advance, the potential for algorithms become increasingly exciting. The future of algorithms lies in their ability to learn from data and adapt to new situations. Artificial intelligence and machine learning algorithms are already making waves in industries such as healthcare, finance, and transportation. One exciting possibility for the future of algorithms is their potential to solve some of the world's most pressing problems, such as climate change and disease outbreaks. By analyzing vast amount of data, algorithms can help us better understanding complex systems and make more informed decisions. However, it's important to remember that with great power comes great responsibility, and we must ensure that these algorithms are used ethically and transparently. Thank you.